Okay, hello everyone. This is our software that is to run count model. So first we can run or install important packages that used to run different count models. So here is important packages. So the first is AER. So uh, run, we can run. So the AR is only before that we have installed. If it is not installed, we can go to package, install package. So we can choose the AER. AER. Uh, uh, AER, find AER, AER. Yeah, here is AER. Then okay. So the package is already installed. So we have run AR. Second, mass, another package. If it is not installed, go to package and install library, Pascal, another package, reader. We can run Heaven, run Tdiverse, run and migrate foreign, another package. Is another package. It is ggplot that we used to run graph, to display graphs. So we can run. Then this is the data. Import the stata data. This is stata data. So we can import by using this command, using this form. So we can run. Yeah, this is what the data. So we can view the data. Here is what the data nature. Count data. This is count data, number of infant days per mother. So this is what days, number of days per mother. If it is 0, there is no days for each mother, but we have 1 days per mother, like this. So we can remove. So then what is name of variable? So this is what the variables. Then show the head, the variable. So this is what label of each variable. Then plot the response variable, which is days, number of days per mother. We can run. This is what number of infant days. If there is high number of excess 0, which is no days. It is 1 days, 2 days, 3 days, 4 days, 5 days per mother. This is shows excess 0. Then summarize the data. So we have 1738 days, or so we can show the table. 4,488 mothers have no experience any kind of days. Here is a days. Then summarize data. Then we have count models, which is Poisson and negative binomial. So we can run. run the Poisson. This is response. Days, factor, region, wells, toilet facility, and offset variable. Offset variable. Log total children ever born data, which is this is what data. This is what the data. So family Poisson link log. Then run the commands. Yeah, this is what count model. This is what count model. Another is negative binomial models. So we have negative binomial GLM and GLM. So we have take the data and run negative binomial. So it is what negative binomial. Another is inflated count models. We have the first is zero inflated Poisson. This is what zero inflated Poisson. Zero inflated Poisson. Zero inflated Poisson models. Here is what negative binomial, zero inflated zero inflated negative binomial, negative binomial, negative binomial. Then run the inflated part. So we can remove this one. So this is what the count part up to here. This is what the count part. But after here, this is what inflated part. This is offset total children ever born. This is what the data. Then run. Wait a minute. So we can run. This is what count model. This is what zero inflated model. Another is zero inflated negative binomial. Then so we have model from this is what response from this up to here we have count models from this up to here we have inflated part. This is what inflated part. Then run the model. We can run. Wait a moment. So we can run. This is what zero inflated count model. Which is zero inflated negative binomial. This is zero inflated part. This is count part. Another is Hartle model. The Hartle model is which is we have zero part and count part. Up to here we have count model. But from this up to here is zero part. So we can run the model. Now we can run Hartle model. So another hurdle negative binomial, hurdle Poisson, hurdle negative binomial. So we can run hurdle model. So here is important model. This is what count model and hurdle zero inflated model. Hurdle zero inflated model. So another is important model comparison. Model comparison, how to compare this Poisson negative binomial, zip, zero inflated negative binomial, hurdle Poisson and hurdle negative binomial. So we have important model comparison. Important model comparison. The first is AIC and BIC. So we can run the model comparison. This is what Poisson negative binomial, and from this we have hurdle negative binomial is smallest value 7893. This is what the best. Here also the smallest value also hurdle negative binomial, so we have the best. Another is log likelihood. So we can run the log likelihood value, log likelihood. So from this, the highest value is hurdle negative binomial 3897. As compared to another, we have smallest value. Another is Wong test. Wong test, we can run Wong. We can compare based on the value or Z statistic. Another is likelihood ratio test. Likelihood ratio test, we can run the model. You can compare based on p-value, which model is best. Another is we can compare the model by using observed and predicted value of the model. So we can run the model. This is what the value. This is not the value. This is not what important model comparison. This value. So we can run every model here up to here, so we can compare this value. Another is number of zeros that capture the model. So based on this, we can compare which model is best for the data. Yeah, hurdle negative binomial is best. So at the end from this, hurdle negative binomial is best. Hurdle negative binomial. Hurdle is best. Hurdle negative binomial is best count model for infancies for this data. So we can take odds ratio exponential of hurdle binomial model, hurdle negative binomial model, not negative binomial. So we can take exponential. This is what count model by using R software. First run the important model, then compare the model by using this model form. We can run the model. So thank you for watching. If you have like my video, please subscribe, share and like my video. Thank you very much.